Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So, it's probably going to be a quiet day. I don't see too many people in chat, but that's okay. Anyone who might be lurking in chat, hey, thanks for being here. I hope you're having a wonderful day. Today, we're going to be finishing up the algorithm archive article for the Gauss's Easter algorithm chapter. Right, it's pretty close to being done. Like, almost definitely close to being done. Let me go ahead and cd the projects algorithm archive over here. And let's do git book serve to show you what we need to do today. It's really just a small amount of things. I think we can really just hammer it out in 2 hours. Hey Amaris, how are you? But right, I hope, again, everyone's having a wonderful day. I know a lot of people are probably staying at home because of, the COVID situation and everything. And I just hope that everything's going okay with everyone. Let me go ahead and copy this, bring it over here. And there you go. I don't know. We'll see. I guess today's going to be a bit of a quiet day, but that's okay. So here's the chapter as we have it so far. Again, I've already corrected the writing, I think. There might be a few things here and there that were wrong, but overall, it's pretty good. Fine, thanks. How about you? I guess I'm doing okay. I'll talk about what happened yesterday as soon as I finish going through this. So what do we have to do? We have to add a few different things here and there. So for the record, I did figure out how to get our... to visualize Servois' table. I think this is pretty good. I kind of like the blue to pink transition because it's Easter. I was like, yeah, I think that's pretty good. Admittedly, sure, maybe blue to pink isn't the best transition for grayscaling. I'm not really sure. I didn't really think about that, but I don't figure we really need to worry that much about grayscaling at this point. Okay, so things we have to add in. We have to add in an image for 6 synodic months. That needs to be added in. We need to add in the image for basically what happens after a full synodic year versus the full, I guess, 1 year for the solar calendar. After that, we have to add 1 year, basically an image of the frequency of a single year, plotted out as a sinusoid instead of a instead of just like the random orbits that we had before, and then of course the full metonic cycle in that way. And I think once we get those images up, that should be it. I think we have all the other calculations up and ready to go. We have, I think, even the example code is here. Bibliography. The last thing I need to do is just basically add the license for the images and graphics, and that's it. That's all we have to do. So we have to add in those images, which we already have mostly, and add in the actual licenses, and we're good to go. So it should be a relatively quick. We should be able to finish it in the next 2 hours. So tomorrow morning, I'm going to spend some time doing the voice recording for the video, and tomorrow might be a video editing stream. Again, I realize we've been doing the Gauss's Easter algorithm thing for a long time. And what always ends up happening with my, algorithm archive videos is we get a lot of people watching for the first bit, for the first few days, when we're learning the algorithm and we're trying to figure things out and all that kind of stuff. But then when you spend, maybe a week or two just working on visualizations and little things here or there, the viewership tends to go down a bit. So I do understand that we might be a bit quiet today. I've decided that I will be taking Sunday off, or as best I can. We'll see how that goes. I know Sunday's Easter and everything, and I should take a day off, but I'm kind of averse for taking time off, So we'll see how it goes. Also, I just noticed something's wrong with the bibliography, so I'm going to go ahead and CD there and see what we got. CD projects, algorithm archive, ls, and now we're going to go into vi literature.bib, and go down to, I guess, wiki, probably down here. Right, title URL. I guess I should also put a year in there, just so the year is going to be 2020. And let me see if that does anything, honestly. I don't know how to rebuild by just updating the literature, but basically the problem here was that there's a comma after this this lunar month thing, and I think that's because it's expecting a year at the end here, and I didn't put a year because I just assumed. I don't know. Maybe we should write the bibliography such that if there is no year, it just puts in the current year. I don't know. We should, as for the algorithm archive Python version to discuss. Okay, so I think we have a clear goal of the things that we need to do. Let me just go ahead and write those down so that I don't forget. because it's just 4 different visualizations, most of which we already have with small scale edits. So let's go ahead and write down those visualizations and go from there. So I just have a scrap piece of envelope here that I'm going to write it on, and we'll go. Okay, so what do we need? We need 6 synodic months. Then we need one synodic year. Okay. Then we need, let's see, 1 year sinusoid and 19-year sinusoid. And I think that's it. So let's go ahead and knock this out, and let's get this done. Again, guys, while we go through this, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I will totally address it as soon as I see it in chat. Actually, before getting started, I do want to talk about what happened yesterday. So I am definitely trying to stream as much as I can here from, my new location in Alabama. Oh, my bitrate just dropped a bit. Hopefully that's fine. Anyway, if you guys have any problems with stream, feel free to let me know. But yeah, so yesterday there was a huge thunderstorm that came by, and there was a lot of wind because of this thunderstorm. So what ended up happening was, yeah, I haven't dropped any frames. So what ended up happening was, there was a tree that fell down and broke the window on one of our cars, and then all of our chairs, which were on our deck, were blown into the lake. So I had to jump into the water and swim them out. And by the time that was all done, it was already 7:00 p.m. Eastern time, and I just kind of didn't do a stream. I really should have. But instead, I kind of came in and I finished up what I could for the algorithm archive chapter. As you can see, there's a lot more done. There's just a few small scale visualizations that I'm going to do here. Again, it just random stuff happened yesterday, so I wasn't able to stream. I don't know. We'll see. Okay, so let me go ahead, go here, Control C from there. And I'm just going to open up a new set of terminals because I feel like opening up a new set of terminals. So let's go to medium, and we'll just make this, drop this down. Oop, and we'll just drop this down here. And we'll open up another one here. Make that huge. That's not huge. There we go. Put it there. That should be fine. Okay. So we're going to CD into projects, Simuleos. Ellis here, CD into Computus. And we're going to go here, CD projects, Simuleos, and Computus over here. Okay. I think if I run the last G++ command, it should still be, yes, it's still there. So let's go ahead and get this done. So I'm going to go ahead and run this visualization that we have right here and see what we have. And also, I guess I'll just open up a whatever terminal. I don't know. Is it 7 terminals? Yeah, it looks like 7 terminals. And I will put this under my face so you don't have to see it. Let's go and run mpv temp video.mp4. And let's look at the video that we have. So here's just a video of the sun, the earth, and the moon all rotating around. Well, the sun's not rotating. The earth and moon are rotating around the sun. And what we should see is that at the 6th month time, the earth and moon should stop. And then when the earth and moon stops, we should see a line drawn between the sun, the earth, and the moon. Yep, here and there. Now, I think what I'm going to do is I'm actually going to basically run the simulation for twice as long. Because there is a small problem with this visualization, and that's that this line isn't completely straight, and that's because of a discretization error along space for the moon. So there's a few things that I want to do. Another thing I want to do is change the line color to be gray. And the reason I want to do that is just so it's easier to see with both a black and a white background. So let's go ahead and do it, and we'll see. Yeah, we'll see how this goes. Let's go to VI. Yeah, I'm in the right directory. Gauss visualization.c++. And here's a synodic scene, which is for the 6 synodic months. And we should be able to draw a few lines here. And I think I can just read in the color. Now, I have to remember, I think the color is the first argument. Yeah, it is. So we have the auto sun at animator, right, earth, moon. Where's our line here? Sun location, earth location, moon location. I'm looking for our lunar half-year frames. No, synodic line. Yep, that's what I'm looking for. So we have add animator here. So I guess I just want to do line color. Something like this. And I'll also put a line color down here for this guy. Okay. And we'll just define the line color up top. And I'm just going to define it as half of every color, so it's gray. I guess I called the other one CLR, so I'll modify that as well. So we'll call this line color. Oh. And we'll change this to... Oh, that's the same color as the moon. I guess it's fine. Doesn't really matter too much. Okay. Change that. And change that. So now the colors should be right, and I'm just going to move down here. Run the simulation for 4,000 frames, which is a large number of frames. And we're going to drop the number of time steps also by a factor of 2, which puts us at, I guess 0.1 should do, I think. And we'll just see how that goes. So let's just go ahead and run G++, then /Gauss visualization. It'll take some time, and also I'm going to run htop just to make sure nothing crazy goes on. And right, hey Fulster, how are you? Right, I hope everyone's having a wonderful day. And we'll just let this run. I don't really have much else to say here, except we're finishing up the chapter and everything, and we'll just see how it goes. The chapter, there will be a pull request for the chapter at the end of today's stream. I'm 100% convinced we can get that done. So here's the Earth, Moon, and Sun. Yep, it's moving. It's moving. And there's a line. Yeah, you can totally tell that line isn't straight. Also, I think it is a bit weird that the line color is the same as the moon color. Let me run that one more time. I thought that was a discretization error. Okay, let's see what do we have here. Let me full screen that. Okay, so you can definitely tell that that line isn't straight, right? Am I the only one that's seeing that? That's definitely not straight. Or maybe I'm just being like, I know it's gonna be slightly not straight. No, that's more than slightly not straight. That's like a full degree off. Okay, so let's see, what do we need to do here? I might just have I don't know what I'd have wrong. Let me just kind of mess around with this a bit. Go back up to the synodic half-month visualization, and we'll see what we can do. Okay. So here we have the moon location. Let's do... If I is less than... Yeah, let's modify this. So this is now a 49. Let me see, what do we have here? So I'll just look at this again, and it looks like we're one frame too little, right? I think we need one more frame. Let me just try removing this entirely from the situation. Here, there, and there. And let's just see what that does. G++. And then we'll run Gauss visualization. See what it looks like. I really should stop procrastinating on my coding theory homework. Yeah, man. Have fun doing your coding theory homework. Yeah, I don't think I took coding theory as a class, but I honestly don't remember much about it at all. It's been a super long time. Right. So let's see. Man, we have like, yeah, okay, I don't know. We'll see. So let's take a look at this one more time. So MPV. And let's just let this run. Oh, where's the moon? The moon's gone. What? How did the... Oh. Right. Yep. Okay. I see exactly what I did there. Let me just do that. Okay. Now let's try that again. I didn't update the moon's position, so clearly it wasn't going to go anywhere. Oh, well. That's what happens sometimes when you're rushing to get code out, you know? Again, this code isn't like performance critical or anything like that. Watching on my TV, and I can finally read all the code without squinting. Yeah, I mean, I'm sorry. The code is as big as I can make it without... it's just as big as I can make it. I genuinely don't have any way... Honestly, I actually can't make it any bigger while still using the same terminal. Like, huge is just as big as I can go. And that's this terminal in here. Okay, so let me go ahead and visualize that. So here we have the sun, moon, all that kind of stuff, and it looks like... I can't tell if that angle is any better. I really can't. Let me see, I'm just kind of putting a straight edge on my monitor. You can't see, but... Yeah, they're definitely still off. Huh. Well, let me see... Okay. Yeah, we should have more precision than that. That looks like it's more than one frame. Do you think I need to actually let this run for a bit longer? So let's see, lunar half year frames. Let me just add 1 to that. And let me see what that does. So we're gonna G++. /Gauss visualization. Sorry, I'm trying to make it like perfectly in line, and it's not quite there. There's like, it's just off by a bit, and I don't want anyone to look at it and be like, wow, okay. I mean, text size, not the angle. No, the angle's definitely off. Okay. So we'll just run this one more time. Let's see what that looks like. Oh, I'm so sorry. I just changed the song on accident. That's what I was looking for. That is still not right. Maybe our calculation for the lunar half year is off? I mean, it could be, right? I can't tell if that's any better. Again, I just have to take my straight edge and see what I got here. I did not expect that this would take any time at all. So let's just keep going. Maybe I can just add 10 frames to this, and we're just going to see what that does. So we're going to do G++, /Gauss visualization, and we're going to run that and see what it looks like. Again, I'm just trying to get those lines. I don't know why you'd have to add 10 frames. That doesn't really make any sense to me. We have the frames for the Gregorian year, which are, let's see, which is going to be, you know, whatever the number of frames are, 10, 20. We'll call it N. MPV. I mean, that definitely looks way straighter. But also, the Earth. Look at the Earth. It's way off. What? Okay. Yeah, the Earth is definitely off in that picture. The line is super straight. Oh, maybe I'm an idiot. Oh, I'm definitely an idiot. Ah, the line doesn't have to be straight. I'm just dumb. The line shouldn't be straight, actually, because 6 lunar months is not half a year, right? So if the line was straight, that would be weird. Why am I so dumb? Okay, so we're going to lunar half frames. 50. Such an idiot. Okay. Yeah, so we had the right visualization before. So what I'm going to do is I'm going to make it so, let's see, world add object, Earth, world add object, synodic lines. So I'm going to grab these 2 lines in here. We're going to do D2D, and we're just going to paste in here. Oh, shoot. Okay, let's, I accidentally lost my buffer. Yeah, I was sitting there thinking the line had to be straight, but clearly it doesn't. Let's see, some Gregorian year frames. This should be fine. Right, so let me change where these synodic lines are drawn. So we're going to do D2D, and we're just going to paste it down here. Add 8 spaces, and we're going to say if, ooh, hello there. Oh, where am I starting to draw the line? It should be, yeah, that's what it is. I is equal to lunar half years. Let's see, lunar half year frames. That's a name for you. Plus 60. Then we're going to do that, and let's just drop down here, and this should be the final visualization we're looking for. Let's go ahead and run G++. Go ahead and run G++ /Gauss visualization. Linux 94. Thank you so much for following. Really appreciate it. I guess you've been using Linux since 1994. Good on you, man. I've been using Linux since 2012. So you've got a few years on me, but I'm catching up. You know, slowly, asymptotically. I'll get there. Okay, let's see what this looks like. We're going to do MPV, and let's just take a look at this. Come on. Oh, crap. What? Where'd the lines go? How are the lines gone? World.add object, Earth, synodic line frames. The animation is drawn from lunar half year frames plus 60. So there's no reason for it to exist before then. If I is equal to lunar half year frames, start using Linux somewhere between Ubuntu 10.4 and 12.10. I don't quite recall. I actually don't even know what those numbers mean. So I don't know what, I would guess 10 is 2010 and 12 is 2012, but that doesn't make sense because I think we're on 12. No, wait, what are we on? I don't know. Sorry about that. Let's see. World add object. If I is equal to lunar half year frames plus 60, then we're going to add the synodic line to 2. That seems fine to me. I don't see what the problem is there. World add objects, Earth shadows 1, Moon shadows 1. Yep, I'm not seeing the issue. Year month is their release versioning. We're currently on version 20.04. Oh, I didn't know that. Interesting. Cool. You learn something new about non-rolling release distros every day. Let's see. If I is equal to 51, we add object. Let me just try doing 60 here and see what that does. So we're going to run G++, Gauss visualization, and look at what it outputs. I'm still using Windows 8.1, and while my computer is working and Windows 8.1 is supported, I think I'll keep that OS. Oh, that's interesting. I didn't know that people, like, honestly, I heard very bad reviews about Windows 8.1, so I'm surprised that you're actually using it and you like it. Do you think compression algorithms can have uses other than data compression in some places we never expect? Yes, I think, yeah, I believe so. See, there's a dot that just appears right there at the center of the sun on frame 60. Let me see if I can. Okay, see here. The sun appears, and then look at the very center of the sun. Okay, I don't normally advise for you to do this. I'm telling you to look at the center of the sun for this visualization, not the sun itself. Don't do that. That'll hurt your eyes. And there will be a gray dot that appears now. Okay, so that means that we clearly can add. Oh, we clearly can add objects. Is there something wrong with? Oh, maybe because I need to do floor of lunar half year frames. That's probably it. That's probably what's happening. Plus 60. Yeah. That's dumb on my part. Okay, I understand. / Gauss visualization, and let's go. I don't like it per se, but it's useful. Oh, interesting. Yeah. A warbear, open stream. Look at the very center of the sun. Hey, you know, I'm not, look, I was going to make a bad political joke, but I'm not going to do that because I am not going, no political commentary on this channel anymore. We're never talking about politics ever again. And all my followers, stop following. Okay, let's see what we got. Let's play the video. And we should see, oh, let me watch that line be drawn. That's a slow animation if I've ever seen one. Yeah, okay. I think that's not bad. Yeah, I think that's fine. Okay. So what we're going to do is we are going to change the background to white. I don't know how to do that, but we'll do that. View haha telija. Thank you so much for following. Really appreciate it. I apologize that I probably completely butchered your name. Please let me know what you want me to call you. If I see you in chat, I'll probably call you View. Probably. Okay. So we're just going to change the background to white, and then we'll have the frame that we need for our visualization. Let's pull down here. Cam world. I think we can just say world.background color. I'm just going to guess. World.bg color is going to be equal to, and I'm just going to say 0001. What does this do? Tell me it does something right. It compiles. It's fine. Maybe I missed something. So let's go ahead and do Gauss visualization. Is 000 is probably black. Also, I just realized this is going to be a red background because I mixed these two. Yeah, why would I think that's going to be... It has to be 111, right? For white? That has to be right. Let's let this run because you guys are going to love this one. This is probably going to be the best visualization I've ever made on Simuleos. I'm at least 90% sure. Let me just put my sunglasses on really quick in case I have to look at the center of the sun again. And, ah, dang, it's black. I was expecting it to be red. Crap. Okay. Let me try this. G++, that's actually a Gauss visualization. Ah, Ping? Is there a problem with ping? Sorry about that. Or did I show my IP address somehow? I don't think so. Love your setup. Super clean and simple. Not even syntax highlighting. Dude, that's how I roll. I actually designed the system to be as simple as possible. That's what I was going for. There we go. White background. And honestly, that sun looks a bit... Yeah, okay. Maybe I need to... Okay. What do you think? I think this visualization will be fine. Yeah, I think it's fine. What I need to do, though, is I need to change the earth and sun shadows a bit. So what I'm going to do is I'm going to... Ooh, hello. What do I want to do? I guess I should do the following. I'm going to comment this out, write this, and go into get status dot get add Gauss visualization. Sorry, Gauss visualization dot cpp. And I'm just going to say get commit dash m adding black version. Oh, hello. There we go. I have about 15 seconds latency, 10 second stream delay on my Raspberry Pi. It could be a deal. Yeah, there might be a bit of a stream delay just because maybe my internet's not as good as it used to be. The stream delay was probably a lot less in Japan. But yes, as far as the setup's concerned, I can provide you guys the template and everything for OpenBox. I just tried to make this as simple and straightforward as possible. That was the whole thing. Minus 2 seconds? Oh, maybe it's just where you live, I guess. I don't know. Okay, so we have the black version. Let's go ahead and set this so it's the white version. What am I looking for here? VI and Gauss visualization dot CPP. Move down here. We're going to change the black background to that, and we're going to change shadow. Anytime we say shadows, we're going to actually set the color to be black. So let's see, what do we have here? Earth shadows, right, moon shadows. We're going to say this, and we're just going to change the color here. So we say vec of, I think I have to do this. 0, 0, 0, 1. I believe that's going to do what we want. Let me see if that actually compiles. I feel like it might not. G++. No, it doesn't. So I think we don't need the curly brackets. That should compile. Crap. Is color a different thing than... Oh, maybe it is. Let's do color. What do we call colors? We have colors up here. They are... Hello. Where you go? Color. It's just color. Oh, maybe I need to... Okay, let's try this again. So let's just go up to shadow. Yep. Okay, here. So we're going to change this to color, and let's try this. Ha! Look at me pretending like I know C++ code. Color of 0, 0, 0, 1. Right, so that's one visualization down, and the next visualization we have to do the same thing for. And then I'm literally just going to check out the previous version. Why do you think that VI won the editor war? I just think if you look up statistics on how many people are using Emacs versus how many people are using VI or Vim, I think you'll find that there's a larger portion of people using Vim than VI. I think that, or Vim than Emacs. That's my honest opinion. So let's go ahead and run G++. /Gauss visualization, and let's take a look at this white visualization. Yeah, it's just a statistics argument. Right, again, if you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Right, just letting this run, and we should have a visualization ready to go. I think I actually want to render this as a set of frames instead of rendering it as a video, and I'll explain why. So here we have these guys. Yes, we have the shadows. And right, so I was thinking about putting this into the algorithm archive. I know it looks kind of weird. Maybe I should have an outline on the sun or something like that. But I think it's okay for what I want to show. I just want to show that the moon is in line behind the Earth in both visualizations. Is this SFML? No. So what we're using here is our own visualization engine known as Gath VL. Let me go ahead and give you a link to that. I think I could just Google Gath VL. Algorithm archivist here. And this is what we're using. It's not super documented, but it's pretty nice. I should stop procrastinating on my AC implementation. I don't even know C. Dude, you just keep, that's all you've talked about in this stream, your procrastination. So, yeah, I don't think that's bad. I think that's fine. Maybe the line should be red. Let me see what happens if we make the line red, you know? Or pink. No, red. We should make it red. But maybe we should make it pink. No, red. Definitely red. But pink. No, red. I just go back and forth. So red is going to be 1 here. And then 0, 0, right. Go over here. And we're going to run. And also, maybe we should make the sun a bit darker. So how would I do that? I guess I'd turn this to a 7. Yeah, I believe that'll do it. So let's go ahead. Maybe we should make the earth a bit darker as well. Oop. So how would I make the earth darker? The earth color is this. So I guess if I change this to 0.3, I guess that does it. So let's go ahead and do G++ dot slash Gauss visualization. And let's see what we have. The text editor Kaquan is starting to be a thing in circles I'm in. It integrates nicely with a lot of CLI tools, Unix philosophy style. I don't know much about it. I haven't heard about it. I'm stuck with what I use. I mean, it's not even that I'm stuck. I like what I use, and so I use what I use, you know? Let's take a look at that. Okay, MPV. Ooh, that made the sun lighter. I think I went the opposite direction here. But that red line. I'm a fan of the red line. Let's go. Okay. I did the opposite of what I wanted to do. So let's change this to 0.75. Let's change this to, ooh, hello there. 0.75. Okay. And then for the sun, we want to change this so it is, what was this before? 0.3, I believe? 5, probably. So let's change that to 0.2, and let's change these to 0.75. Something like this. I'm just, you know, just kind of, oh, 5, I think. Let's see what that looks like. G++ / Gauss visualization. I'm going to have to take a look to see how we would render frames instead of a video, because I just want to pull a frame out of the video instead of having to take a screenshot. I think that's slightly nicer. Right. It also comes with anything, wait, if it also comes with that annoying paperclip from Microsoft Office. That's what's on my mind, actually, but I like your stream better than homework right now. Dude, you should definitely do your homework. Don't use me as an excuse not to do your homework. Oh, that is a green sun. The earth color is better. Oh, that's a green sun. Let's drop this to, how do you make yellow? Yellow is a combination of, what was it before? We had a yellow sun, and then I got rid of it. Get diff Gauss visualization .cpp. The sun color was 110.5. That's gonna be red, blue, a little bit green. How does that make yellow? I think I'm just bad at colors. So let's just I mean, if the sun looked too green, right? Ah, that wasn't what I meant to do. Crap. Well, let's try it again. The sun looked too green. Yeah, it's RGB. So if the sun looked too green, then I should probably remove green, right? But how does red and blue make yellow? What? I thought red and green made yellow. So then why do I have 0.5? It looked yellow before. I definitely had a yellow sun. That sun is just gonna throw up, isn't it? Maybe I'm looking for orange. So if I'm looking for orange, okay, well, let's just sun color here. Red and green, RG. Oh, it's RGB. See what that does. When you combine blue and yellow, you get a new color. It's called Blello. Why am I just so bad? It's okay. Once we get this visualization in, it's trivial to get the rest of what we need. So I'm relatively happy with where we're at. I think we can get everything done today. In fact, we will get everything done today. That's still not what I was looking for. I mean, look, that's ugly. I mean, no offense, but that's not what I was looking for. Okay. Red, green, blue. Red and green put together should be. Change this back to 1. Change this back to 1. What does this look like? That should just be yellow. Like we shouldn't. This should be yellow. Gauss visualization here. So I wanted 0.75, 0.75. That's what I wanted. I was changing the hue accidentally because I don't remember how color works. We should do a color theory stream. That's what we should do. That's definitely a thing, and I think that'd be pretty cool. You might want to pick color wheel for that, maybe. Nah, I'm too stubborn for that. Okay, so that's yellow. Let's just drop this to 0.75, 0.75. And 0.75 here. And let's go to... Oh, hello. I have too many terminals. Okay, here we go. Gauss visualization. Let's see what we got. Green is yellow and blue. So you get yellow by reducing the blue. So green. So red, green, and a little blue. Yeah, I think this is gonna be what we want. I mean, trust me. I've never gotten this wrong before. I mean, if you ignore the past 5 minutes of stream, you know, never ever gotten this wrong before. And if you also ignore all my questionable color choices I've had so far for all my videos and the algorithm archive, dang. That just looks ugly. Why? All right, let's change this to 9.5. All right. Let's see what that does. Oh, well. We'll just try to figure this one out. A little bit of blue, right? I don't know what I'm looking for anymore. I feel like maybe I should... I mean, at this point in life, I should know what I'm doing with my life, right? But I don't, because I'm just completely lost. Oh, well, it's fine. Maybe one day, you know, a reason for living will just... Ooh, that got dark really quick. I'm going to stop that sentence. What happens if we add a little bit of blue in there? I might just use the color wheel. If we don't get anything done in the next 2 attempts, we'll just use the color wheel. Brown. I mean, hey, a brown sun. A brown sun is still a sun. We're just revolving around a giant pile of crap, you know. Which, hey, it's not too different than the current situation of our world. I think that looks identical. That isn't that the same thing? Did I forget to compile this? Am I just dumb? Don't answer that. Oh, I'm making it more gray. That's what I'm doing. So if I want it slightly more red, a little bit green, I know what I need to do. I got it. I understand now. Okay, red, green. Let's change that to 0.9. We're going to change this to 1. That's what I want. Control C. Let's run that. Gauss visualization. All right. Let's see what we got. We need complementary color function. I think that's too much effort. I think really we don't need anything, honestly. Let me get some water. This is gonna be exactly what I want. Hey, Trash Talk. How are you? Bam! Look at that green sun. What? Oh boy. I did it backwards. I meant to do 1 for red, and I did 0.1. Alright, let's try that one again. Gauss visualization. Let's go. Thanks, Boring, for pointing that one out. Oh boy. We'll get there. We'll get there one day. I don't know if that day's today, but we'll get there. Bless RNG. Yeah, it is kind of RNG at this point. This is what I want. I promise this is what I want. This is the visualization we go with, no matter what the sun color is. And there we go. That is actually the color I want. Now, does this line make sense? I think I think that's the visualization I'm putting in. I think that's fine. Yeah, I think that's fine. The whole point is just to show that the moon is behind the Earth. That's the whole point. That's all I need to show. I think that's fine. It was a nice green, though. Yeah, it was a nice green. I think I should save that for the next time I need a green. Okay, there's one more visualization we have to do. So what I'm going to do is I'm just going to yank, grab those colors, and I'm just going to put it down to the next visualization because we're going to need the same colors for that visualization there. Paste down here, and the shadow color. We're going to have to update that, aren't we? I guess I already did that, didn't I? Yeah, I already did that. Okay. Right, so now all we have to do is make this so it outputs a series of images instead of outputting a video, which is definitely doable. I just have no idea how to do it. So let's just go to this terminal here, and we're just gonna do something. I don't know what we're doing, but we'll find it. We'll figure it out. CD into GathVL. LS here. What am I doing? I need to... Coda Kiwa, thank you so much for following. Also, I apologize that no, I think that was 1 second ago. I think I got that right on time. Okay. So let's see. I'm gonna go into viviztest.cpp. Let me just take a look at what am I doing here. I'm encoding cam.clear encoders. I'm encoding this. Add encoder, video encoder. So we probably have different encoders, right? So let's just take a look here. LS. I'm looking for an encoder. What would an encoder look like? See, we have images, we have layer, PNG encoder. So probably, if I just do PNG encoder, this will probably work. And we'll just call it temp.images. All right. See what that does. G++. Yep. That's what I expected. Where would we keep the encoders? Probably see the include encoders. All right, L is here. VIPNG encoder. Oh, maybe it's just PNG because the last one was just video. Let's just do DT here. Write that. Go over here. G++. Didn't work. Probably because we need to remove the 60. Dang. Okay, let's see what we have here. PNG encoder takes in what arguments? It takes in... It doesn't take in a size? How does it not take in a size? No, it doesn't. What if I just do cam add encoder and we just DT here? Does this work? I don't know what it's going to do, but let's just see. No, it doesn't work. Okay, PNG encoder, int count, Cairo surface. I wish I had an example for how this works. You know, like at one point we need to create examples for how to run this visualization software. But that's not this point. That's a different point in the future. It looks like all it needs is PNG encoder. I think I spelled that right. Oh, that does compile. So now I just need, what is it looking for? PNG encoder temp image? I don't care. That's probably fine. Let's go ahead and run Gauss visualization. And let's see what we get. Okay. Right. So we are generating a bunch of images. Wonderful. We'll just let those images generate. I actually don't know how many images we're generating 4,000 images. Let me just show you my temp directory. I don't know if this is kosher or not, but here we go. We have 862 images out of 4,000. So how's your day? I hope everything's going well. Nice weather we're having, right? That's my favorite drink. 1588 out of 4,000. Still like 10 seconds left. So if you have any deep, dark secrets you want to share with the chat right now, yeah, go ahead and do so. I'd love to hear it. But nothing that could get you banned. Like, don't say you killed a guy or something. probably a bit too far. I don't know what I'm talking about today. I'm so sorry. I should just stop talking. Stop talking until all these images are generated. That's what's gonna happen. Right. 2, 5, 6, 8. We might actually be there. Let me go into Mirage. Temp image 0 to 500. Ooh. This is just chugging along, isn't it? Oh boy. Well, let's just see what happens. There we go. Okay. So I guess I'm just gonna scroll on this. Nope, no, that doesn't work. Let me just... Oh, yep, everything's frozen now. Let's just... Oh, well. You went full retard? What do you mean? My stage math interpreter is not starting? I'm sorry, man. What do you mean you went full... What do you mean? Okay, let's do another LS of temp. See what we got here. It looks like all the frames are now generated. So let's go ahead and take a look at this. And, yeah, let's try to get the right frame. I don't know. You're going to get insane, bro. I don't know. I really like this algorithm, actually. It's one of my favorites. One of my favorites that I've seen in a while. You know, it's just fun. And yeah, it's good. I'm a fan. So let's see. I should be able to... boy. Okay, let me close out of here, and let me just take frame 3000, and we'll see what that looks like. Well, maybe let's just take the last frame. We know the last frame's going to be fine. Yeah. So we're going to take frame... Actually, let me just open it up. Here's what I'm going to do. I'm going to CD into the appropriate directory in the algorithm archive. CD contents. Computus. L is here. CD into resources. And I'm just going to move temp. Let's see. Temp image 00. We'll just do 3500.png. And we're going to put this here. And we're going to say it's synodic. We'll call it synodic. Synodic half year.png. Okay, let's take a look at that. Mirage, synodic half year.png. Yep, that's the visualization I wanted. I'm gonna have to modify it a bit, but let's go ahead and get that next visualization done. Let's see. I'm on your website. I see a lot of stuff you made. Yeah, cool. Thanks, man. Oh well, no, it does. And my SO is asking me to go to sleep. Well, I think I won't get my homework right now. See, Amras, have a wonderful evening. And yeah, I hope you finally get your work done, man. Okay. So I'm gonna go ahead and remove those files. So remove temp image 0 star here. And what am I doing next? I'm going to go into this terminal here, and we're gonna modify this so it's the orbit scene instead of the synodic scene. Now for the orbit scene, I'm going to again increase the number of frames to 2000, and half the frequency. That was an IP address I accidentally just typed in there. And I think, am I supposed to half the frequency or double the frequency? Maybe I'm supposed to double the frequency. Let's just see what this does. I'm going to yank and paste this and put some lines in here. And then I'm going to, what am I going to do? Let me think. I'm going to git diff computus, Gauss visualization .cpp. Let me take a look at that bottom part of the file. What was it before? Just cam add encoder, video encoder. That's what I'm looking for. Q here. Gauss visualization. I'm just going to run the video just to see what it looks like. I think that's it. Right. Go over here and let's just run this. So G++ /Gauss visualization. Let's take a look at that visualization, see what it looks like. It's just 1 year of synodic time, and well, actually 1 year of full time. I don't know what that means. Let's do MPV. So here we have the sun, the earth, the moon, and they should stop there. Right, so we're gonna have to change those line colors, and I think I'm gonna change them to red as well. So let's go here. What did we? Where are those line colors? So where's the arc? Arc, and the color is just gonna be red, just pure red. I think maybe that red is too red, but it's fine. It's fine. We'll just see what people say about it. I think maybe what I should do. Let me change this a bit. I'm gonna add false here. I'm gonna add false here. Well, maybe I'll change this to true. I'll change this to true. Okay, and what I'm gonna do is I'm gonna say this is gonna be called line color. And this is also gonna be called line color. Okay. And let me see, did I set any other colors here besides potentially the background color? What I'm going to do is I'm going to just add the line color to everything here just because I feel like it. So we're going to say, oh, what did I set? I called them true. So true would mean algorithm archive. So let's go up to orbit scene. Okay. One more up here. And this is going to be a Boolean for algorithm archive version. So say bool, and we'll say AAA version. Okay. And the only thing that's going to change is this. So if AAA version, we're going to do this. And then else. And I'm going to set those colors as they were set before. Now, do we use line color? Here? It's only used there. Okay. Great. So, oh, for the shadows. Right. It's used for the shadows. It's a bit weird. Let's see. It's a bit weird how Minecraft isn't free, but everyone acts like it is because everyone already owns it. So I'm going to call this shadow color. Yeah, okay. I've never owned Minecraft, nor have I ever wanted to. It's not really my thing. But I totally see why it could be other people's thing, right? So we're going to say, where's our line color defined? It should be defined there. So we just defined it as red, but I actually want to define it as black. So we'll have line color and shadow color. Shadow color here. Oh, we're going to have to define, okay, I know what we have to do. Let's go ahead and DD here, DD there. Okay, let me think about this. So the shadow color needs to be black in this case, and black is going to be 0 of everything. Okay. I'm going to, where am I? I think I'm in the right directory. Git diff Gauss visualization .cpp. And let's just put the right colors here. So we have, I think here I can just go ahead and remove the moon color. And then are we in the orbit scene? No, we're not. So let's go ahead and go here, there, and put color. All these colors just need to go here, except remove the pluses, you know, because who needs them? Okay, so we have the sun color, the earth color, the moon color, the line color, and of course the shadow color. Shadow color. And this is going to be equal to, in this case, just white. 0. I believe that's fine. And then we just remove the colors here. So that should be 1, 2, 3, 4, 5, 6. 6x for all of these guys. So we just redefine them if we're working on the algorithm archive version. And I think that is... I grabbed the wrong colors. Crap. So we're going to change this to 1, 1. The earth color is going to be 0. I think it's just this. The earth color before was 1, 1, 1. Oh, the sun color had a 0.5 here. And this was a 1 and another 1 there. Okay. So I think these are the right colors. We have the earth color, the moon color, and the line color in this case. Oh, I think I'll keep the line color red, actually. Yeah, I think I'll keep the line color red. I think that's fine. Let's see. I just saw the stream. I had to program a calculate. I had to program to calculate the date of Easter program for my job. Oh, cool, man. Nice. Which C++ version? C++ 11-ish syntax, I guess. It's a bit weird how... Okay, I'm going to go to the bathroom and think about how I want to design a D&D character generator for functional paradigm. Cool, man. Have fun. I don't know why you need to do that in the bathroom, but yeah. So we'll DD there. And yeah, I think these are the 3 colors that will change. The shadow color changes from white to black. The earth color and the sun color changes. And let's just do the same thing up here to this guy. 1 second. Yep, so now we're going to add a Boolean. Bool, and it's going to be AAA version. What do we have here? a DD here and a DD there. You know I'm using VI when I type DD all the time. Anyone ever tell you that you kind of look like Woody Harrelson? I don't know who that is, but I'll take that as a compliment. Thanks. I probably screwed something up. Sun, color. Yep, probably just, let me... I asked about version because new ways to do color is sun color without the equals. It has benefits. Sure, it does. I'm not a C++ programmer, honestly. I'm just doing what works here. I mean, look, I've written C++ code for decades, for literally a decade. Not decades, I shouldn't have said that plural. But I've written C++ code for 10 years. I don't consider myself a C++ programmer just because I don't really care about a lot of C++ stuff. You have to really just, you know, if you're writing C++ code, you really got to just learn everything about it. And it gets really kind of messy, you know, in my opinion. And the moon color also needs to be here. And let's see, so that means we can remove this guy and that guy. And right, 7x, should be 6x, 6x, okay, there and there. Right, so we have the sun color and the earth color changing, so that means I have to define the colors for those guys. So that would be up here. Okay, so we have the earth color, everything else should be fine. Okay, that should be fine. It's definitely the most complicated language by far. No doubt it's by far. We keep trying to add C++ to the algorithm archive, and every single time we try, people just get angry. Like, just viscerally angry at some of the choices, you know? Like, it just, I don't know. It's just, you can't, there's no standard style for C++ is a problem. So you end up just, yeah, it's just messy. It's just so hard to write anything consistent for, you know? Because C++ 14 is dramatically different than C++ 11. Yeah, this will do, I guess. Those lines are white. They are not supposed to be white. Let's go down here and let's change that. Arc. Let's see, arc. These are the Earth's shadows. But what I need to do is add an animator for... oh, these are synodic lines. This is a different visualization than what I was looking for. Orbit scene. Yep, that's what I'm looking for. Let's look for the next arc. Should be here. Earth arc. No, wait. Is that what I'm looking for? Make shared arc. Sun location. Add animator. Moon arc. Yeah, maybe this is what I'm looking for. Yeah, it has to be. So we'll call this line color. Okay. And we'll also add a line color down here. Yep. And I'm just going to check all the colors just to make sure they look how they're supposed to look really quick. Gauss visualization. C++ has become a landfill. Anything and everything that people once wanted but now stinks is thrown in, but nobody claims it. I mean, that's the problem, right? Like, modern C++, you can write in a purely functional style, which is great. Like, don't get me wrong. It's really cool that you can do that. But at the same time, it's kind of... It's so dramatically different than any of the code that you're used to writing, you know? In C++. So then there's the question. Like, so the main thing here isn't... The main problem with putting C++ in the algorithm archive wasn't to do with syntax, right? You can always add more syntactic sugar to something and make it look better. The problem is that C++ is a paradigm. Ooh, that's okay. Well, that's a bit different than what I thought it would be. Right. And that is because let's change this background color. So the default color should be black. G++. Gauss visualization. Let's see what that looks like. Okay, I'm back. I think I have a plan. Anyway, the problem is that, like, you can write C++ code as literally anything you want. Like, you can write it as functional. You can write it as imperative. Okay, that color is definitely wrong. Like, maybe I just forgot to define a color or something. Let me see. What do we have? Black hole sun. Let me see. What do we have here? So I think because I didn't define a shadow color. Probably that's the reason. So we should define a shadow color here as... it's alpha. Yep. Let's try that again. G++. Gauss visualization, then we'll take a look from there. And now the song's stuck in my head. Wait, what song? Wait. I don't know what we're talking about. I'm sorry. I don't know pop culture. Um, maybe I should. People keep bringing up pop culture on stream, and I know nothing about it. Soundgarden, Black Hole Sun. Oh, okay. Cool. Sounds fun. Yep. So we have this. That looks pretty okay to me. So let's go down here. G. Let me just make sure the other scenes work, just because just make sure it works. Okay, so we're gonna do G++, Gauss visualization, and let's see what it looks like. It'll take just a bit longer because we're doing twice as many frames, but not too much longer. Honestly, this works pretty well. I'm a big fan of how this library works. It handles things pretty well. I'm admittedly right. Okay, that's not quite right. I think it's because I didn't define a shadow color in the synodic scene. So we have line color, and we also have to define a color, and this is going to be shadow color. And for regular, it's going to be 1, 1, 1, 1. But for the AAA version, it's going to be 0, 0, 0. Okay, let's see. Where do we have the shadow define? It should be here. And we just set the colors to be all zeros, so let's go ahead and modify this to be shadow color. And down here, we're going to do the same thing. Right, DT. Oh, that's not going to work either. Yeah, whatever. Okay, write that. Let's try that again. That. And run Gauss visualization and see what happens. It's from the 90s, though. Pearl Jam era. Fair enough. I really should learn. I don't listen to music, so it's not something that I think about pretty much ever. You know, I know it's very weird. It's just I don't do music. It's not my thing. I know a lot of people give me a lot of crap for that, but so yep, this looks okay. That looks fine. I still think the sun looks a bit weird, but meh. Let's change this to false. I just have to make sure I can get the appropriate video, the appropriate videos as well. Gauss visualization. And then we'll take a look at that video, and everything should be good. And then we can just encode this as a set of PNGs and take the file we need. Yep, that should be fine. Do you drink beer or wine? I don't do alcohol, actually. It's just like everyone's like trying to relate to me in some way. They're like, "What about this song? Do you like this song? Do you like this type of alcohol?" It's like, "Yeah, I don't do music or alcohol, man." And then they'll be like, "What do you do?" It's like, I program crappy C++ code. That's not right. But I think I know why it's not right. Oh no. Which one is it? It's this one. Yep. I need to change the background color to be that color. And then we'll do G++, Gauss visualization, and let's go from there. May I quiz you to see if you can tell what a regex does? I probably don't. I'm very bad with regex. What's your favorite mathematician? Probably Gauss. Gauss is a pretty good mathematician, especially after going through this algorithm. I have a whole new respect for him. But next time, when we go through a new algorithm from a new mathematician, oh, actually, maybe Strawson. If you count Strawson as a mathematician, I think I would probably count him as my favorite. Volkner Strawson came up with a number of incredibly cool things, and I'm just a fan. You know, ever since I saw the Schoenhage-Strawson algorithm, I'm like, dude, that's amazing. And yeah, I know Schoenhage also probably, had something to do with it, considering it's in his name. But I just really like Strawson. He's done a lot of cool stuff. What about Godel? Come on, man. Fair enough. I have no idea what that does. RN. I mean, I guess regex is similar to Vim or VI, so I don't know. I'd have to think about it. Got to go for a bit since it's a birthday and there's cake to get. Yeah, man. Have fun eating cake. I hope you have a good evening as well if you don't end up coming back. Let's go here. MPV. Oh, Oh, it encoded it as a bunch of frames. Let's just do Mirage, temp, image. No, I forgot to run it. That's what happened. But I did just realize, no, that should work. Okay, let's run it. See what happens. This is a not, I think. Cake is always a good excuse. Right. Oh, guys, I have to tell you something really dumb. Let me open up Zernal PP, and I need to show you something really stupid. Okay, so I'm currently at my parents' house, and I know, you might argue it's kind of dumb to quarantine with your parents because, your parents could die and everything of coronavirus, and I get that. I totally get that. But on the other hand, I was fundamentally unable to sleep in Boston, so I kind of figure this is a fair trade. I am currently in a room where there's 2 beds. Beds will be green, and my desk will be red right here, okay? So the only way for me to get in, I'm just going to draw myself here, maybe in blue. So here I am. Yep, I have very large legs for some reason, but the only way for me to get in is to like sit on the bed and then move over here in some sort of weird crunch position. It's really silly. What's the name of the program where sometimes you draw plots? Yes, new plot. So like basically what I'm telling you is I have no room in this room whatsoever. Every single time I have to enter to sit on this chair, like I have to do some weird ab exercise to do it, I don't know. I don't know why I said that. I was waiting for the simulation to run. Okay, so let's see. What do we have here? I'm gonna run Mirage. And we're gonna look for temp image 0. How many do I have here? 2,000. So probably what I'm looking for is image 1800 is what I'm gonna look for. .png. Give it a second to load, and then we'll take a look at it. And then we should have two of the four visualizations done. Small scale modifications to be made. Yeah, okay, large scale modifications to be made. The shadow color is wrong, and also the... Oh, I see what I did. Try it again. Gauss visualization. Okay. I hope you guys are all having a wonderful day. And if not, I hope you're all having a wonderful day. I don't know. Yeah, I realize that it's there's a lot of stuff going on in the world right now. I mean, like, with coronavirus, a lot of people are losing their job. I think unemployment is higher than it's ever been. It's insane, at least in the US and in several other countries that I'm aware of. But yeah, I'm hoping that, at least for 2 hours a day, during this live stream or whenever you watch YouTube videos or something, you can just kind of chill, hang out, talk a bit about algorithms or whatever you're interested in. I think that's fundamentally one of the most useful things I can do as a content creator. Just provide some sort of content for you to consume and just get back to normalcy, I don't know why I'm talking about that right now, but yeah, I don't know. It's crazy. 400,000 cases of COVID-19, but 15 million jobs lost. The cure is worse than the disease. Oh boy, we're going to get real political real fast. And I kind of want to cut that off because the more we talk about politics, the more everyone just gets mad. I don't know. The economic toll is going to be a lot. And I'm worried about where that's going to go. And I think everyone else is as well. But we'll see, maybe things will jump back in a way they never could have before, I don't know. Yeah, this is fine. I'll just modify it in just a second. Yeah, this is fine. Jobs will come back though. I don't want to get into this either. Yeah, I figured this is all anyone's talking about, right? And yeah, I think it is worth talking about, definitely. But if it's the only thing that you're talking about, the only thing that's consuming your mind, you're never going to get any work done. And now, look, I know probably you don't have to get any work done. Like probably, it's interesting. It's nice to talk about, but at the same time, I kind of feel like, oh, I didn't. Ah, crap! I just overwrote the file that I needed. Okay. Well, we're gonna have to. I meant to call this something else, but I just pressed enter. Orbit. I guess we'll call it orbit.png. Move a synodic half year to orbit.png. Okay, let's just rerun this again. Right, so we're gonna go over here and we're gonna modify this so it's a synodic scene and this is true. It happens. Okay, now we're gonna run G++, Gauss visualization, and then we'll have all the visualizations ready. Back with cake. The regex I posted matches everything that isn't a printable ASCII character or a new line. Interesting. Jobs will come back though. US has a flexible job market, so people can be rehired when it is blown over, hopefully. I'm not an economist, so don't take my word for it. If pausing society to prevent a pandemic catastrophe results in the loss of 15 million jobs, our economy was already broken. Yeah, right. Again, this is all very political. People will constantly talk about this, and I mean, I'm sure next year people will still be talking about, you know, COVID-19 and its effects on the economy and all this kind of stuff. But I mean, who knows? Maybe even we'll land ourselves in some sort of depressed state. I mean, not just emotionally, but I mean like economically speaking. It's hard to say, but what I will say is that I think we won't see as much of a loss of jobs in the end, but I think we'll see more of a transformation of the economy, and that's going to be interesting. We'll see what happens. No politics. To be fair, I said nothing about political leaders, nor did I say anything about how we're handling the situation. I just said in the end, I don't know. I don't think we talked too much about politics. I think we just talked about the ramifications. You know, you'll have more visitors. Yeah, I mean, that'll happen. What is Clappy? I've never seen that emote. Nice. Okay, but yeah, again, I figure that as far as this stuff is concerned, it's just nice to return to normalcy, and I think some part of the stream is just that, just returning to normalcy, you know? So we'll let this run, then when we get the visualization, we should be able to copy it back with this right here, as soon as it's generated. Let me see how many images we have so far. LS temp. Oh, we're almost there. We're about 3/4 of the way through, or 7/8, actually, I would say. Let me get some more water. And then we have one more visualization to do, and then we have everything ready, and then I can work with it after stream just to get that algorithm archive PR up and ready to go. Again, tomorrow, I'm going to do a video editing stream, and it looks like we can get the video out on... on Saturday, which will be great. It's the day before Easter. I know I wanted it out like 2 weeks ago, but it takes time. You guys have seen me the whole way doing this kind of stuff. It's not easy, especially when I'm kind of rusty and getting back into the swing of things and all that kind of stuff. Take a look at the visualization, Synodic half year. So here's the visualizations we have so far. Here's the orbit scene, and again, I have some slight modifications. I have to like draw, like I have to say like what this difference is in phase, and how there's a slight difference there. And these guys are all ready. They're the Servois table for the 1800s and the 2000s, and then also this guy here. So good. I think we have everything ready to go. Day before Easter is perfect. Maybe. But on the other hand, I was going to name this When is Easter? Right? Because that's what everyone's going to be Googling. But if it's the day before Easter, everyone already probably knows when Easter is, you know? I'll take 7/8 over 3/4. Yeah, anyone would, right? Okay, so the last thing I need to do is generate one last image. So we're going to go ahead and Control C out of there, or quit, or whatever you do in Vim. I don't even know. I mean, I know what buttons I'm pressing. I just, you know, it becomes second nature, and you don't really think about the buttons you're pressing. I'm going to open up Julia. Speaking muscle memory, this is just what happens anytime I'm confused. I just open up Julia, and I'm going to be using plots, and that might be all we need. So then we're going to create an array that's going to be element size. A is going to be equal to, what do we want here? We're going to do, yep. Okay, I know exactly what we're going to do. I just need to think about it. Big fan of eighths in general. I mean, I guess if you like music, there's eighth notes and quarter notes and stuff like that. Okay, so we have A is going to be equal to, ooh, how do we do this? I'm going to say it's going to be sine of 2 times pi times I over resolution for I equals 1 to resolution. Something like this is what we're looking for, and we'll set res equal to 1000. What does that do? I have no idea. Let's go ahead and plot that guy and see what it looks like. Oh, that was exactly, so the very first line, if you go to, here, I'll show it to you. It should be on GitHub. Yep, that's what I was looking for. So if you go to GitHub, let's just go to github.com, and we should be able to find scripts. Okay. I meant to put this out on the day, so, no, there it was, Computers 2020. So the very first line is, Easter will be held April 12th, 2020, the Sunday after the video is posted. So I meant to put this out on the Paschal full moon, which was yesterday, but I just wasn't able to get it. So then that's literally how I start the video. Easter will be on April 12th, 2020, the Sunday after this video is posted. If you happen to be watching this in the future, Easter will also be held on the 4th of April, 2021, the 17th of April, 2022, or the 9th of April, 2023. In fact, here's a plot of all the dates of Easter for the next 100 years. And then that's kind of how I start the video, talking about why Easter's hopping around so much, all that kind of stuff. So that's exactly how it started. Right, so we have this visualization, and that's going to be the frequency. So now let's go ahead and create B. And what I'm going to do here is I'm going to say B, actually let's do A. Okay, so B is going to be of a different frequency. So it's going to be this, and we're going to multiply this by times the frequency we have for the lunar year. So let's see, what do we have here? It's going to be VI Gauss Viz dot CPP lunar year here. So it's going to be multiplied by 29.53 times 12 divided by 365.2425 for I is equal to there. Now if we plot B, can I do plot AB? Is this going to work? That does not do what I expected it to do. So we plot A. Yeah, this is probably what I wanted. Plot A. And then if I do plot exclamation mark B. Okay, that's what I wanted. Almost. Oh, I see what I wanted. Yep, I screwed up. So B is actually going to be equal to this. Yep. Now let's try plot A. And then again, plot B. Where's a plot? There's a plot. Ah, crap. That's also not what I wanted. Okay, let's see. My plan for my D&D character roller is to randomly select top-level information like race, class, background, etc., and then pass that information to functions that need it, each function representing a separate paragraph of the character description. Cool. The frequency was not as high as I expected, so I think what I need to do is actually multiply this by 144. Oh. So now if we run plot A, and then we do plot B, is this what I'm looking for? That is actually what I'm looking for, I think. Let me go ahead and full screen this guy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it shows that there's an offset of 11 days. It should be between this point here and this point here. That's what I'm looking for right there. Nice. So I think this is the data I'm looking for. What I'm going to do is I'm going to modify this a bit. So I'm going to do the full metonic cycle and see what it looks like. This is a new plot extension for Julia. No. I'm just using Julia right now. This is just plots.jl. But I could use a new plot. I probably will use new plot in just a bit. So I'm going to say A is equal to this. And I'm actually going to do A2. And we're going to say this is going to be sine of 2 pi. But I'm going to multiply this by 19. So it'll be 19 times this. Okay. And if we plot A2, we should get, yep, so that should be 19 peaks. And now I'm going to create B, and I'm going to call this B2, and I'm going to multiply this by 19. Okay. And now if we do plot of A2, okay, and then we plot on top of that B2, ooh, that's a plot. That is super hard to read. Maybe we can't do this visualization after all. Because the only information that's necessary here... Let me explain what I was trying to show here. Let me go to Zernal PP. I'll open it up and let's talk about this a bit. And let me hear what you guys think about this. So what I was trying to show here was the metonic cycle. This was a friend of mine talked to me about it and said this is probably a good way to visualize it. Lowkey 372236. Thank you so much for following. Really appreciate it. So what we'll do, man, I say I really appreciate it, like I don't really appreciate it, but actually I really do appreciate it. You know what I mean? Like, I just say it so much that it comes off like I don't care, but I do genuinely care, and I do really do appreciate the support. I'm sorry that it just comes off that way, you know? Maybe only plot the peaks instead of the whole wave. Let's think about that really quick. Okay, so first for the 1 year, we have a sinusoidal pattern that looks like this. And the blue will be the solar year. Okay? And then in gray, we'll have 1, 2, 3, 4. The lunar year. Oh, let's try that one again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here. Okay? So here we have the lunar year ending at this point of 12 lunar months and the solar year ending at this point. So I wanted to highlight the fact that there are 12 days between the lunar and solar years. Hey, Dave, how are you? That's what I wanted to show, right? Then I wanted to show that after 19 years, okay, and this is the visualization I was trying to show now. After 19 years, here's our plot. And again, I'll use the same notation as before. We're going to have okay, let's try that again. We'll have 1, 2, 3, 4, 5, 6, 7, ... 8, 9, 10, 11, 19. 19 ends here, right? And then I wanted to show the lunar one, which is going to be, whoa, super crazy. Whoa, look at this. You know, ... Whoa, look at the super crazy thing. Whoa, but then they end at the same point. Wow, it's a miracle. Basically, what I wanted to show was that after 19 full years, the two peaks line up, or the two frequencies end at the same point. That's what I wanted to show, but I don't know if this plot, let me see, where's the plot? Oh, I'm gonna have to redo it, aren't I? Oh no, which terminal it was? It must have been this one. I don't think this plot shows that at all. I think this plot's pretty bad at that one. So if you look at this, right, this is that very same plot I was trying to show us. I just showed, right? And so the idea is you have, so it goes 12 to 0. What do you mean? Sorry about that. I don't know what you mean. It goes 12 to 0. I have an idea. What if instead of, let's change B2. Instead of being lunar months, we change BT2 to be lunar years. Okay? So now we're going to plot A2. And then on top of that, we're going to plot B2. And okay, we need one more frame. But they would end at the same... No, they wouldn't. So clearly there's a delay. Clearly there's a delay between... So... Oh, man. This is really hard. I could try to plot only their intersection points, but then we run into the whole... Maybe this visualization just isn't going to work, you know? I mean, look, if we plot A and we plot B, let's plot A, and then on top of this, we're going to plot B, right? We get this plot right here, which kind of shows what I'm looking for, right? Like, this will at least show that, you know, this point here and this point here, there's a 12-day offset between this point and this point. We can at least show that. We can at least show that. But then I don't think the 19-year thing is going to work. After 19 years, they meet, and the lunar year normal... Wait, they meet, and the lunar year and normal year reset to 12 days difference again. Right, so the way you think about it is every year, so every solar year, the lunar year is 11 days short, right? So after 19 years... roughly 19 times 11 is going to be, maybe it's 11.5. I don't know how this math works out, actually. We did the math before. Okay, so every year, we're 11 days short. So after 19 years, we're 218. That's wrong. Whatever I just did was wrong. TechleDev01, thanks for following. Oh, the subject is fascinating. Thanks so much for saying that. I made a script that prints text. Cool, man. Dude, keep up the good work. Progress. Okay. So, yeah, something's wrong here. Her Hots and Plots, thank you so much for following. Really appreciate it. Nice name, by the way. Okay. 19 years. This should be 19 times 19 is 361, which is close to a year. Are we 19 days off? No. Each lunar month is 29.5 times 12, so that's 354 days, roughly, right? It goes progressively. 12, 11, 10, 0, or it's just 12, 0. It goes progressively, right? Like every full solar year. Oh, I got it. I think I understand now. It's not okay. Right, I got the units wrong here. It's going to be more than 19 lunar years. It's 19 solar years. Wait. How does this go? So it'll be every 12 solar months. Oh gosh. Every full year. I don't know how to think about this anymore. So every full year, the lunar year, every full solar year, the lunar year is 11 days short. So it should be after 19 lunar years, we should be one full year behind. That's what I was imagining. But actually, I think that intuition is wrong. How does the Metonic cycle work? Crap. I spoiled something? Wait, I don't know what you spoiled, because, I mean, you didn't say anything that I didn't know already. Right. So the tropical year is longer than 12 lunar months and shorter than 13 of them. Right. I know it's 11 days off. So the Babylonians applied the 19-year cycle since the late 6th century BC as they measure the moon's motion against the stars. That doesn't really help me at all. So it should be 235 synodic months. Let me just multiply 235. So we'll do 235 times 29.5. Okay. And then we're going to divide that by 12. I don't know why I just divided that by 12. Let me think. Divide by 365. That's 19 years. Okay, right, because the cycle isn't... Okay, right. So the cycle isn't... Okay, it's 235 synodic months, not 19 tropical years. Right. Right. Okay. That's fine. So after 235 synodic months, we're at exactly 19 years. So I think I just had the lunar and solar years mixed up a second ago or something. Okay. So then, what do you guys think about the sine wave visualization? Do you think it's probably a bit... I don't know. I can't think of a good way to make it work out exactly. Let me just move this over here. We're going to plot A, and then we're going to plot on top of that B. Let me see something over here. There. Okay. I think this might work better via a visual, like, if you could go through this graph, or this plot here, if you could go through this plot, and you could just zoom in on different sections and try to find the difference yourself, I think this would work. But as just a static visualization, I don't think it does. I don't think it does. I need to think about it a bit more. And so I think what I'm going to do is I'm just going to drop this visualization for now. And I guess that is going to be fine, right? We'll just go ahead and put the visualizations we have into the algorithm archive. Because I don't think that's going to... I don't know. I need to go. See you, Trash Talk. Thank you so much for coming in. Have a wonderful evening. And hopefully I'll see you around next time. piece. So let's go ahead and just do some basic cropping of the images that we have. Actually, no, let me just put the images that we have into the algorithm archive and put the licenses on them. And then I'll fix up the images off stream, and then we'll be ready to go. So let's just go ahead and do that. And yeah. And I think I'm just going to remove that section from this chapter. It's not essential either. It just would have been nice. I just had another way to interpret this, and so if I just remove this. As a final note, there's a small offset between the metonic cycle. Let me just make sure I removed what I was supposed to remove. Sinusoid. I'm so sorry. DD, yep. This is, I think, all I want. So if I just remove that, we should be okay. Yeah, let's just go ahead and add the images in and, right, put the licenses on. C or C++. It is technically C++, but its spirit is C. You know, like, this is kind of all the code I write. You know, it's, in principle, it is C++ code. I use certain C++ structs, like, you know, vex and things like this, but it is written very, very much like C, just because that's what I write code as. It's what I do. Okay, so we're gonna CD into projects. Oop. Algorithm archive, contents, computus here, and let's go. So we should have an image that we're adding in. So where's that image? I'm just gonna, yep, here it is. Yank, add, and we're just gonna paste here. Okay, so center here, and this is gonna be, I think I call it synodic half year. Yes, synodic half year.png. Oh, hello. Okay, and we'll just call it synodic half year. Okay, yank that, and we should have another add in here. Right, so let's paste, and this is just going to be called orbit.png. Orbit, and we'll just say full year. I don't know. All right, full year. That's what we're calling it. Let's move down to the licenses for images and graphics, and I'm just going to go ahead and open up VI tree traversal, just because I know I have it here. Tree traversal.md, move down here, and we're just gonna grab one of these lines over here, so we have it. Again, I mean, images and licensing is a necessary part of the project. It's something that we didn't do appropriately when we started, and now I think we might be going a bit overboard, but it's I think it's kind of essential to have here. Okay. So right, I guess we're just going to, how did I, oh, right, this is correct. Okay, so the image, I'm working on a game engine, and it's really hard to handle memory leak because it's got a lot of optimizations to make. Right, yeah, game engines are another beast entirely, especially because a lot of game engines work entirely on a GPU, right? And I do a lot of GPU programming, and it's just hard. The whole thing is just hard. So let's go here, quit, ls resources, and let's just do it. So we will call, the first one is going to be named, what should we name it? It's going to be called Servoice 1800 colored table. Wonderful name for a wonderful piece of art. And we're just going to say Servois 1800. And I think that's correct. Yank. Yep. And so now we're going to change this one down here to the 2000, since we can. And that's going to be 2000 over here. And now let's change these guys to what they need to be. So this is going to be the synodic half year. Oh, there we go. This is going to be just synodic half year.png. Okay, and down here it's just going to be orbit.png. Okay, and this is going to be changed to full year orbit, I guess is what I'll call it. Okay, let's write that, and I'm going to cd back a directory and then one more directory and just run a git book serve just to make sure it builds and everything looks okay. And then that's everything I need to do besides some small scale image editing, which I will do on my own. There's something wrong. Year 2020. It's wrong with the literature.bib. vi literature.bib. Here, year, and I need to add a comma there. Okay, let's do git book serve now, and it should work. Oh, well, I just dropped something. That might be useful. Just 1 second. What happened to it? Ah, there it is. Ah, wonderful. Okay, let's grab this guy. And paste this here. Take a look at the chapter. And I do have some, again, small scale things to do, but I think I'll do them off stream. So here's the chapter as it stands right now. Again, serverless table. Here's our image for that, algorithm. Let's see, second serverless table. Yeah, I mean, it looks pretty dang good. Let's just make sure all these links work. Link. Okay, clearly they don't. There's a problem with github.com/Laos. What? This doesn't work anymore? How does that? Oh, is this what? Oh boy. Oh boy. Oh, that's wrong in every single chapter. Well, good to know. Oh no. Sorry, I made a joke earlier and yeah, okay. Well, let's go ahead and fix all that. Crap. I guess I'll fix it in this pull request. Oh man, that is wrong everywhere. We'll just do s https to https cg yes. Oh no. All right, well, let's just go ahead and fix that now while we're thinking about it. Crap. Okay, well, we're gonna go back and let's just do grep -rl https. cd tree traversal vi tree traversal https. Oh, what? I must have just accidentally. Okay, fine. It seems to be fine. I guess it was just that one file. It's not the first time. Do you syntax highlighting for any language? No, I do not. I don't find syntax highlighting to be too enlightening for my own programming. What is this? Welcome back to another episode of Simuleos. It's Monkey Boy 12. I'm so sorry. Please don't leave. Why? How do you have so many, like, how does everyone have like the perfect clip for my stream? Like, do you guys just, is that what people do on Twitch? Is everyone just clipping all the time? That was a joke because, man, I'm sorry. I know I've done some, I'm sorry. Let me go ahead and go, actually, let me check something really quick. Is this correct? Yeah, okay. Yeah. Okay, cool. By the way, if you guys have seen any, like, or you've heard any like clipping of audio or anything like that, feel free to let me know. I don't think it's clipping, but it could be at times. And so I need to like fix the volume. What could have happened is when I transferred my equipment here, some of the dials got a bit touched and stuff like that. Right, so let me take a look at this chapter and make sure that those links work. There's plenty of clipping on Twitch. I meant like audio clipping, like if my if I'm speaking too loud and the microphone's picking it up and it, you know what I mean? There's lots of clipping on Twitch. James Schloss, this link should work, and it does. James, all of them work. Nice. Okay. Minor crackling, I think. Okay. I'll rewatch the stream afterwards, and we'll see what we do. I'll see what it looks like. I think, guys, I have some, again, minor visual editing to do. You know what? Let me take a look at this chapter one more time. Let me take a look. And let me see. What did I think maybe I can just finish up the images right now in 10 minutes. So let's just do it. I don't think there's that much to do. Computus all I need to do is fix up these images here. Here we see the sun at the center with the earth and moon starting the year at an angle of negative pi over 4 from the horizontal axis. The initial location of the earth and moon are initially shown as an outline. CD Computus. Oop, us. Let's go to VI Computus. Shown as an outline with A at their center. With an A at their center. I didn't put an A at their center. That's what I didn't do. Okay, right. After a full synodic lunar year, 12 lunar months, another outline of the Earth and Moon are shown at position B. And after a full Gregorian year, they're shown in position C. An arc is then drawn, showing the difference of 11 days between the Earth's position after the synodic year. Okay, so we have some minor things to do. I'll go ahead. Yeah, I can do it. I can do it now. Let's just do it now. We're going to CD into resources, LLS, and let's just do GIMP of orbit.png. And on top of this, I'm actually going to open up, oh, man, freaking, where am I? I'm going to do projects, algorithm archive, contents. Anytime I see a GUI, I just feel like I'm a 90-year-old man and I can't figure out what I'm doing anymore. Computus? It's just, I think my problem with UIs is that, you know how like every time you walk through a door, like your mind is no longer focused on whatever it's supposed to be focused on? I don't know what I'm trying to say, but like there's a study that basically said that if you're trying to like remember something, or if you're thinking about something, you have like a train of thought. That train of thought is immediately lost every time you open up a door or something like that. Or maybe not immediately lost, but your train of thought can be lost when you walk through a door or something like that. Like this is something that people talk about or used to talk about all the time, right? I feel like with UIs, I tend to get that feeling of just losing my train of thought so much with them, you know? I'm crackling. So let's do image, and I'm gonna add some guides to this image. New guide by percent, 50% horizontal. Image, guides, new guide by percent, and vertical. Okay. Now I'm just gonna cut this guy up, something like this. We're gonna want to make it, let's make it size 500. Let's do 500 by 500. Oh, that might be a bit. We'll see, 500. And let's see what that looks like if I move this down here. That is just a bit too small, I bet. Yeah, it's a bit too small. So let's increase this to 550 by 550. 600 by 600. Let's just go. Let's get crazy. 600. No need to. We have room. Okay. So I'm gonna go ahead and cut that, and then I'm gonna do file, export as, and this is gonna be exported as synodic half year.png. Export that. Replace. Export. Oh no! Did I just do something really dumb? Oh, I bet you I did. No, I didn't. This is fine. This is fine. Okay. Do layers. Close that. And now I just need to put an A and a B and everything on this guy. I made a script to calculate the primal root of a number, aka the sum of a number's prime factors. Nice, man. I mean, seriously, everyone in this community is doing super cool stuff. Fantastic. I don't need door frame to forget something important. Hey, Sim Chat. Hey, that's your fan. How are you? Alternatively, you could crop the image to content and expand the image size with centering. Right. Is there music playing in the background? There is music playing in the background. I can increase. That's something everyone was saying the music was fine, but I feel like it's too quiet and I feel like people can't hear it ever. So I might just. Oh, that might be too high. Let's see. It was negative 30 before. So if I just increase it to negative 28.2 or something, can I set this manually? Maybe that's better. I don't know. We'll see. We'll see what people say. Sorry about that. Okay. So I'm playing around, seeing what number various starting numbers land on if you apply this process repeatedly. I don't know if debugging template code is something that fits your criteria. Oh no. I thought I was imagining the music. No, the music's definitely there. Right. So what I'm gonna do is I'm gonna just say A. Oh no. see. That's too big. Let's try changing that one to 20. That's probably fine. And I'm gonna move that on top of here. Yeah, let's change the font and a bunch of things just to. I always use Linux Libertine. I don't know. Maybe that's not the best, but that's what I use. Linux Libertine. And then I'm gonna bold that guy, and let's change this to 22, 24, 25, 28. Looks like 28's the winner. Oh, actually, is it the winner? Does this fit inside the moon? It does, just barely. Yeah, we'll go with that. Why not? Let me zoom in a bit. And actually, I'm going to move this down so it's at the center of the Earth, and this over here so it's at the center of the Earth. Something like that, and then we're going to move that there. Perfect. Yep, okay. So then I'm going to have to do another one here. What size was it? 28 or something like that? I don't remember. Here, Linux Libertine. Libertine. We're going to bold that guy, and we're going to change this to 28, I believe. Right, I think that's correct. And now we're just going to move that to be on top of the moon. Does that work? Ooh, that is close. Might want to make it a bit smaller. I was going to say, this sounds like a job for SVG, but then you added text, so there goes that plan. Hey, it probably was. Probably was. We probably could have used SVG, but too late now. I'm working third shift now. Just got to figure out adjustment to eating work times. Yeah, good luck, man. Anytime you have to like change your work schedule or something, it's not easy. But yeah, I'm sure it'll be fine. Let's change this to 26. 24. I don't know. We'll just see what happens. I mean, this might be an ugly image, but we'll see. 24. Okay. Let's move this to be... Oh, that's already in the center of the moon, isn't it? Well, let's just do C. Okay, A is going to again be 24. And this is going to change to Linux Libertine. And that looks too big, doesn't it? We got to bold that. No, maybe it's fine. So we'll just put this over here. Is that in the center of the moon? No, I feel like the center of the moon's there. And that should be right. Okay. So A, we're going to have to move to there. Okay. So now we just have to put the B's down. So we're going to change this to B. A. 24. And then we'll change this to Linux Libertine. Oh. Yep. Welcome to Simuleos, the channel where we pretend. I guess every time I do this, like I edit something in GIMP, I always feel like I'm fabricating data. Like, I know I'm not, but like, I always feel like I am, you know? Like, I feel like everything that I'm putting down is just, you know what I mean? Like, it just feels wrong to edit up. Like, sometimes you'll publish a paper, right? And sometimes, you know, the graph doesn't look so great. So you open it up in GIMP and you don't change the data, but you move the image around, and it just feels like that was supposed to be a B, I think. It just feels wrong. I don't know. I know it's not wrong. It just feels wrong. Does anyone know what I'm saying? I feel like someone out there has to know what I'm saying. Move this. And I guess I'm just going to zoom out a bit. Oh, zoom out a bit more. Zoom out a bit more. Okay, or not. That doesn't seem to work. So let's move this over. Oh, nope, not that over. Crap. I just wanted to change the size of this guy. A here. Change this to 24. And I think I need to bold it as well. Let's go here. And we're just going to bold that guy. And then we'll move that down to the moon. Okay. That's not bad. Let's go ahead and new file. Export as, and this is going to be orbit.png. Okay. Export. Replace. Export. Okay. So now I think that should be ready for algorithm archive consumption. Ish. That should recompile it. Okay, let me catch up on chat. I'm sorry. Computer modern is ugly. Sort of a joke, but not quite. Yeah, but computer modern is what LaTeX uses, so I understand. I don't think that looks so bad. I mean, maybe it does, but maybe it doesn't. I said I would put... Should the red line be over the A and the B? Like the A and the C? You know what I mean? Like, should it... Well... Okay. This one doesn't look so bad. It is what it is. I think the point kind of gets across. Why not make those diagrams in LaTeX? That way you get the best of both worlds with SVG vector graphics and text typesetting. Dude, I do actually. That's what I use Nuplot for. I always spit out a tech file that you can then compile. SVG and LaTeX is garbage. Complete with the pain of both. Yeah, right. Like Tix is rough. Should I put a? I feel like I should put a. This is okay. This is fine. You know, I think this is okay. Why don't I make both diagrams? Let me catch up on chat here. I was gonna say this sounds a lot like a job for SVG. Without modifying why not make those diagrams in LaTeX? That way you get the best of both worlds with SVG vector graphics and text typesetting. I want to share my primal root script on the Discord server. In what channel? Probably either off topic or general. Both are fine. I was suggesting SVG, but ticks. Oh man, I know ticks. Gauss on his Easter algorithm, it's not possible to present here the entire analysis that led to the above formula. Yep, I wrote that in here. There should be a quote in here from Gauss where when his compatriots asked him about, you know, he told everyone, someone asked like, how does this work? And he said, the investigation by which the formula is found is based on higher arithmetic, for which I presumably cannot refer to any publication, which was the 19th century equivalent of saying, you're too dumb to understand my genius. Like, it's beautiful. This guy had, I mean, yeah, sure, he's a genius, but he had definitely the arrogance to match. So anyone who might not have been here before, let me go ahead and give you guys a invite to the Discord channel. I will copy that, and then the only way I can get it into the terminal is by doing this. I know that sounds dumb, but hey, paste that there. And right, what link did I give you guys? I gave you guys. It expires in 1 day. Sure, fair enough. That's fine. Okay. If you guys haven't been there already, yeah, feel free to join. I think this is a good time to go ahead and close up shop. It's fine. I still don't like this image, but it's fine, right? We'll see what people say about it. I think it's not so bad. Okay, so let's go ahead and go to here. Who's live? We have Pokurimio who's live. Das Valdez, Adam13531, wonderful guy. In fact, all these guys are wonderful people. Dowright is live. If there's anybody that you want me to raid at the end of stream, feel free to let me know. I'm going to get a sip of water. Maybe hear what you guys have to say about it. But yeah, if you want me to raid someone, let me know. Other than that, I will be spending tomorrow a little bit of time tomorrow morning before work starts, doing some voice recording for the next video. And tomorrow will probably be a strictly video editing stream. It might actually not even be on science and tech. I realize the content is about science and tech, but I always feel bad about being in science and tech if I'm not doing something that's science and tech related, you know? So I feel like maybe the video editing will be in art. I'm not sure. It's going to be a bit of a different stream if I do a video editing stream, but we'll see how it goes. I mean, it usually takes me, 2 to 4 hours to video edit, and I think this should be relatively quick, so we'll see. Glockner8211, thanks so much for following. Strager, let's see what he's doing. I did say Glockner, thanks for following. I think I just said that, and then I forgot that I said it. But yeah, help coding, teaching C++. Yeah, cool. He's doing C++. So yeah, we just did some C++. That seems good to go. Cool. Okay, guys, thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And let's go and start that raid. Strager. Cool. Thank you guys so much for coming in, and I will see you guys next time for the next episode of Simuleos when we continue to, or basically finish up Gauss's Easter algorithm. It's been a long journey. I'm glad you guys have been here for the most of it, and I will, yeah, see ya for now. Bye, guys.